Hey guys, Sean here. Hope you all doing well. In this video, we'll cover regression problem again with a little bit on forecasting to actually visually see the model prediction. Okay, let's do it. Let's create a file, regression with forecast, and again, let's import all the required libraries. I will cover a little bit about normalization. What is its importance of normalization? So it's basically actually I have done normalization on the target variable here to just check which one works better, and I also will link a useful article on which actually I did this experiment. So yes, let's get started. We'll load the data from the data repository. It's energy efficient data. Again, I'll provide a link for the data set below in the description. Now let's print the first few lines. Okay, there are two target variables here in this data set, y1 and y2. We will be taking only y2 for our analysis. You can experiment for doing a prediction for y2 on your own, but here in this we'll consider only y1. Now as a common step, so let's split the data set into trained and valid data set. Sample fraction 85%, and we'll take random state 2, and then we'll take out all the trained data from the original data frame to get valid data frame. Okay, let's do this. Okay, now let us separate the target variables here. Since we have two, it is a little different from what we have done before. Okay, let us do this. Pop targets of 0. So basically we are popping two columns here, y1, y2. traindf.pop targets of 1. So we'll do the same for valid. Train, let's rename it to train y1. Train. Okay, or else it's better. Okay, let's take that same thing and train y1, y2. Sorry. Now let's do the same thing for valid y1 and valid y2 by popping out targets, both of the targets from the data frame. Okay, now let's do this for y2. Okay, valid data frame dot pop targets of 1. Okay, this is done. Now let us scale the data frames. Maybe okay, let's take the numpy, let's convert it to numpy here only. Values, not values. Okay, training, both of them are separated. Splitting is done, and now scale. Let us do scaling here again. Scaling inputs, stats as usual. We'll be doing scaling with respect to trained dataset. Okay. Stats mean divided by stats of standard deviation. Same thing, we'll repeat it for this one. Validation df minus stats of mean divided by stats of standard deviation. Okay, scaling. Okay, now let's this is the difference from what we have done before, scaling the target as well. So as I told, we'll take only y1 in this, train y1 minus train of mean divided by train y1 of standard deviation. Okay, same thing we'll do it for y2. Just do it, but will not use it. y2 dot mean dot standard deviation. Let's do it for y1. Valid minus valid d1 y1 mean minus this one divided by standard deviation. Same thing repeated for y2. Okay, the mean and then standard deviation. Okay, this is done. Print valid. Let's just do a little sanitary test till now what we have done so far. Okay, let's run it. Okay, as you can see, it is normalized. Okay, now converting it to a numpy. Yes, train data, train df dot to numpy. We'll do the same thing for validate the valid data, valid df dot to numpy. Okay, now prepare data sets as usual, like converting numpy into df dataset. Prepare dataset. We'll take in batch, data label batch, and then shuffle buffer, and then as usual we'll convert it into Tensorflow dataset by tf data dot dataset dot from tensor slices. We'll pass in tuple with data and labels, so that way we don't have to pass it separately, the data and the labels in the fit function. Shuffle buffer dataset, then do a batch and of batch, and then prefetch it, and then return dataset. Okay, now let's take in train dataset from the above created function. Train and valid. Okay, maybe we will rename it a normalized train y1, normalized train 2, just to have a comparison between non-normalized and normalized effect in the prediction. Let's do this, and then we'll define batch size to 32 and buffer size to 550. Okay, now train dataset, prepare dataset, pass in data, train data, normal train Okay, let's create both the types of dataset here. Train on batch size and the buffer. Okay, same thing for valid dataset. Okay, valid. Prepare dataset, valid data, valid y1, batch size and buffer. Okay, now let us do the same, repeat this for normalized y1 and y2 y1. Normalized dataset, norm train y1, no, train y2. Okay, now the dataset is created and finished. Now let's build a model, a very basic model. Maybe in future videos I'll also show how we can actually experiment by creating multiple layers and what could be the dense layer input value. We'll do an experiment in future videos. So basically this one, how many dense units that unit is specify. There is something called Keras tuner. We will explore that in coming videos as to what should be the optimal value for each dense layer. So it will give us some suggestions on what we can use for a particular number of layers. So here we'll just go with our basic model with two layers, two dense connected layer and one last layer for the prediction, and MSC. I'll use loss function as MSC, and then optimizer to be SGD. Sorry, layer, it's not layers, it's optimizer dot SGD, and then we'll use metrics as accuracy and MAE, and then we'll compile it. Now we have two datasets here, normalized and raw dataset. So we'll just first train without normalized data. History is equal to model.fit train dataset, epochs, I'll take it 10 for now. Validation data, valid dataset. Okay, this is done. Next, do a normalized history, training with normalization. Okay, norm history, we'll define a norm history, model.fit. Now we'll pass in normalized dataset, train dataset, comma, epochs, I'll take 10 only. Then validation data to be norm train dataset. Okay, yeah, valid, sorry, valid dataset. Okay, now let us plot. Or let's do a sanity test, maybe without normalization, just for our indication. Let's just print it with normalization. Without normalization. With let's do a sanity test. Okay, it's working fine. MA is decreasing, and if you can see here with 1.16 is without normalization and 1.17 is the value for normalized data set. So it's already giving us an indication that now we have to use a normalized data set. Okay, let us MA is without normalization 1.669. Whereas for with normalization the value is in 0.17 something. Let us check it. 0.17, yeah, 0.1719. So we are on already having what normalization can like how can this normalization be useful, how it is useful in our prediction. Let us now also plot. Okay, as you can see, normalized data is performing well, so we'll be using normalized data from now on. We'll just comment it out. And then let's do the plotting. So we'll be plotting accuracy versus accuracy and MAE and as well as loss. Accuracy is not giving us much idea, because so we'll remove accuracy here. Its value is very low, so not be useful even visualizing it in the graph. So let's remove that, and then we'll keep only MA and loss metrics. Now metric validation, metric norm history val underscore plot. Okay, epochs, range matrix. Now let's plot dot figure size to be 15,10, fixed size to be 15,10. Plot on x-axis will plot epochs, and on y-axis will plot metric. So for each epoch we'll come to know how is the matrix that is getting trained. Okay, that is being trained, sorry. Plot epochs, validation matrix, label validation plot. Okay, now let's also okay, legend, add legend, and then show. Okay, plotting is complete. Now let's do this again. Let's check if the plots are coming fine. Legend, okay, there is an error here. Okay, yeah, the graph shows that it is working very fine. The losses are decreasing and MA is also decreasing. Now let's add one more thing in this video to just do a forecast on our prediction. So forecasting is just like plotting the original value against the predicted values. So now let's see how well our model is performing. This gives a visual idea about our model performance. Index row, then we'll take valid df dot enter rows. We'll iterate over the data frame, and data is equal to row dot values, np dot new axis. So prediction, as I said, that np dot new axis is just to add one more dimension to it, depth to the data, because TensorFlow model needs the data in that format. So forecast dot append prediction 0 0. Okay, now forecasting is done. Now let us validate it with our labels. Valid y1. We'll just take in last 50 values here to get like zoomed in plot. So let's do this forecast, valid data, x-axis, range, valid data, we'll call it original data, original or forecast. Okay, original. Then we'll plot figure, fixed size 1510, and then plot x-axis, comma, original, label, original data, original data, original, not original. Okay, that is also plot prediction, forecast, label is equal to prediction data, original data and prediction data. Okay, plot dot legend, and then plot dot show. Now let us see the forecast. Okay, maybe we'll also calculate the MAE for our model by, since we have done the forecasting or prediction, just pass in the labels and the predicted in absolute error. Then we'll pass in the original labels, comma, forecast. Okay, print model MAE. Model MAE. Okay, now let us do this. We'll see the plot now of our forecast. This is loss and MAE plot, and now let us okay, something is really very wrong here. Okay, now title. Okay, I have used valid y1 instead of normalized v1 here, so let us change that. Okay, now if I plot Okay, this is fine, this is fine. Okay, yeah, as you can see, our model is predicting quite good, so we can further improve on this, but this seems fine to me so far. With only 10 epochs, maybe we can improve it further better by training it more. And our MA is final MA is 0.172, so we're just training it for 50. If we train, let us see what will be the value. So we can see, okay, it's improving better. Okay, forecast is also better again. Okay, 1 point. Okay, it's almost the same. Let us train it for 100 maybe, and compare our values, like if it is improving or not. Maybe we can also use bigger value and then pass in like early stopping callbacks. We'll do that again in the further videos. Early stopping. Okay, okay, this is not bad. Let us check our MA. MA is 1.168. okay, it is not performing good actually. Let us add one more. Okay, let us add a dropout here to check like if it is add regularization. So because in the previous graph, if you can see, the validation curve is actually improving. Sorry, it was going upward. Now I think it should be fine. You just compare the plots so you can get some idea. Okay, 16 okay, 200. Let us train for more epochs and let's see how it will perform. Okay, it's decreasing. MA is decreasing. 19, 18, 19, 17. Okay, graph is also looking better. Let us see. Okay, 167. No, it's not, but the MA is decreasing. Let us see if we can reduce the loss MA value. So here actually early stopping could help us better, but I'll cover that in another video maybe. So now let us train it for 500 epochs. So as you can see, MA is decreasing in 1, 3, 1, 4, 1, 2, 1, 2, 1, 1. Sometimes it is decreasing. Maybe you can train more, furthermore here. Okay, not bad. 1, 1. So it's 1, 1. So it's gone good. Like maybe you could train more, and then we'll get some good performance. Okay, I think we can also do experiment on this, and if we can now, let us do the plotting prediction, plotting for regular data set. That is will not normalize the data. We'll just use the data as it was. Let's see the MA value here. Okay, the plot itself is not looking good. And okay, now let's change it to change it to norm valid y1. Okay, okay, let us check our MA. Not bad. MA is 2.04, whereas our previous one was 0.11. MA, finally MA with normalization 1 without normalization is 2.04. Two point zero four. 2.04. Okay. Okay. Normalization. Okay, so this is the conclusion, guys, in this video. So sometimes the target for the target column also we may have to do the normalization. It is always good to try out which works better for our data set. Sometimes it may work and it may not work. This I got this realization from in one of the problems that I was solving, so I thought I'll make a video on this and then show how it could differ from normalizing even the target columns. So this is it, guys. This is how it makes a difference. Just try things and come to an understanding of what works better for your model and your dataset. Okay, that's it. I'll provide all the links that are required for this and the code also, and we'll catch up again in the next videos with more topics covered in the TensorFlow. Okay, guys, thanks. Hope you guys enjoyed. Thank you.